class we studied the graphical representation of motion. Right, distance time graph when it was parallel to the x-axis, the distance time graph when it was parallel to the x-axis, when it was the body was in body it means that the body is in rest. Fine. And then distance for same distance time graph, if you are drawing the graph like this, then this graph is not possible. Okay, because it's not possible that time will remain the same and the distance will keep on increasing. It is not possible. Okay, so this graph is not possible. This graph is wrong. Then for DT graph, for the straight line, if the DT graph is a straight line, then what? It is a uniform motion. And for this type of motion, it means for this type of graph, it means that it is accelerated motion, and accelerated motion is always non-uniform motion. Okay, velocity time graph, if it is parallel to the x-axis, means time axis, then the motion is said to be uniform. It means that the velocity is same throughout the journey. Okay, and if it is a straight line, then it is non-uniform motion. It means that it is uniform accelerated motion, uniformly accelerated motion. Okay, because velocity is increasing, but there is equal increment in the velocity in equal interval of time. Okay, and for this type of graph, VT graph, the acceleration is non-uniform acceleration. Fine. AT graph means parallel to time axis. If the graph is drawn parallel to x-axis, then the acceleration is uniform. It means that acceleration is not increasing throughout the journey. It is uniform. Okay, fine. And then if the graph is like this or like this, it is non-uniform acceleration, because acceleration is increasing. Fine, acceleration is increasing, or here or in this graph also acceleration is increasing. So it will be called as non-uniform acceleration. Okay. Okay. Now we will study today the derivation of equation of motion through graph. Okay. Fine. So if you will be conscious, then it will be too easy. Fine. It is too easy, but it seems like it's very hard to derive. We have a graph, a VT graph. Okay. It is drawn VT graph. This is your x-axis, this is your y-axis. Then let us suppose this is our some initial velocity in u. Fine. This is our initial velocity u. Now the body has started moving and increasing its velocity. Fine, to a certain number, and to a certain velocity. It attains a certain velocity, final velocity. Let us suppose it's v. Fine, final velocity v. Okay, certain velocity v. This is your only what? Graph. This is your only graph. Now what we need to do? We need to only just join the points. Means your graph is only this. Fine. Your graph is this. Now we need to join to the y-axis and x-axis. Okay. We'll join like this, and one more. We'll join like this. Fine. Okay. This is some time t. Any time t. Fine. Means the body has moved. The body has started with the initial velocity. Initial velocity is what? U, and attains a certain velocity, which is final velocity, which is v, and it has traveled how much time? T time. Time is your t. Okay? It has traveled t time. Fine. This is our graph. Now, for the first equation of motion, what we need to do, we have here, let us draw name the points A, B, C, D, E. Okay, it's already O. Fine. O, A, B, C, D, O, E. These are our points. Fine. For the first equation of motion, what is our first equation of motion? V is equal to U plus AT. How we are going to derive this? V is equal to U plus AT. V is equal to U plus AT. Okay. So what we have to do here, we have to find the acceleration. Acceleration is what? The formula for acceleration we have read in the previous section. What was that, Arham?
The formula for acceleration was it was displacement by no, that's not the one.
It is changing velocity by time.
Okay, Advika, you there?
No. Is it
Hello?
Yes.
final velocity minus starting velocity by something? I don't get displacement.
Okay. Advika, can you tell me what is the formula for acceleration?
V minus U by T.
We have final velocity minus initial velocity upon total time.
Fine. Okay. Razi?
Yes.
No, not total time, just time actually, ma'am. Final velocity minus initial velocity by time.
Razi, can you tell me the formula for acceleration?
Yes, ma'am. U minus V upon T.
U minus V upon
Sorry,
T.
ma'am. So, V minus U upon T.
V minus V upon T. So everyone is knowing the formula for acceleration that we have read so far. It is final velocity minus initial velocity upon time. Or we can write change in velocity upon time. Okay? Or we can write change in velocity upon time. So from here, from graph, what we are drawing here, A is equal to final velocity is what? Here, final velocity is what? Is it V? From the graph, we have written this, no? From the graph only we have got this information now that initial velocity we have taken u, final velocity v, and time is t. Is it? Yes or no? No one is. Hello? Am I audible? Hello? Hello? Am I audible?
Yes, ma'am, you are audible. What happened, ma'am?
Yeah, I asked you that from the graph we have got this information now, initial velocity u, final velocity v, and time t. So can we put these values in this? Final velocity is v, or we can do, because we have to do this using graph. So initial velocity u is what? Here you can say OA. Can we write OA? Can we write this final velocity OB? Hello.
Yes, ma'am.
Can we write this time as OE?
Yes, ma'am.
Yes, ma'am,
from
you
the
can
graph.
write it.
Okay, then final velocity is what? OB. Just putting the values in this equation. Final velocity OB minus initial velocity is what? OA, and time is OE. Now we'll write the terms. Like this is your V, this is minus U by T. And then what we have got, bringing this T to A. Okay, bringing this T to, yes, bringing this T to the left hand side, we'll get AT is equal to V minus U. Means we can, sorry, V minus U. It means that we can write, if we are going to take this u again in left hand side, then we will get v is equal to u plus at. Will we get this? This is our first equation of motion. Okay?
Oh my God.
Fine. This is our first equation of motion. Now for the second equation of motion. Second equation of motion, we have to think about the what? Distance. So the area under VT graph tells us about the what? Distance. Okay, and in second equation of motion, all we need is distance. Okay, now how to find the distance? Now see, what is the area under this VT graph? Our main graph is this only, no? Our main graph is this. So what area can we get from this graph? Okay, so area that we can get is this much area we can get, right? So if we'll find the area of this OACE, okay, OACE, it's like trapezium, right? Is it trapezium or not?
Yes.
It is trapezium. Okay, so if we'll find the area of OACE, then we'll get the distance. Okay, because distance is what? Distance is speed into time, right? Velocity into time. Fine. As far as we have read about the distance is what? Speed into time, right? It means that velocity into time. So the area under this graph, we'll get what? Distance. Okay, so finding the distance using this area, we'll write like this. Distance is equal to distance. We'll use S for the distance. Area of what? O B C E. Sorry. OACE. Okay, this area we have to find. So now we'll see that we can cut this trapezium into two parts, in triangle and a rectangle. Can we do this? We'll get a triangle and a rectangle, right? So we will do what? Find the area of triangle and find the area of rectangle, and then we'll add both of them. Fine. So area of triangle ADC. Is it ADC or not? This ADC. Is it ADC or not?
Yes, ma'am, it is ADC.
Right? ADC, ADC, this is our triangle, plus area of rectangle. Rectangle what? Rectangle is what? OADE, right? OADE, okay? OADE. For area of triangle, what is the formula for area of triangle? Half base into height, okay? Half base into height. Here base is what? Base is what? AD. Is it AD?
Yes.
Base is AD and height is CD, right? Height is CD and base is AD. Means that we can write AD into CD. Now plus for rectangle. Rectangle we
Actually,
need
ma'am, it
10.
is S equal to AR. Ma'am, after AR, what it is written inside bracket?
OACE.
Ma'am, what is O?
Trapezium. Trapezium. OA.
Okay.
O is your this origin.
Okay, ma'am.
Okay. The area of rectangle will be what? OE into
Ma'am,
OA,
into OA.
right?
Ma'am.
OE into OA.
Yes, ma'am.
OE into OA. Now AD into CDC. See this CD and this AD. Is it equal? Is it equal?
Yes, ma'am.
Because these are parallel, so it will be equal, right? So how much is this? How much is this?
Which?
AD. AD is how much?
80.
AD is how much? Because up to B it's V and up to A it's U, right?
So, ma'am,
Up
AD
to B.
equals to BC.
Yes. What you say?
Ma'am, अच्छा AD you are asking. Ma'am, AD is
I'm
similar.
asking. No, I'm asking for AD. B for ball. AD.
Ma'am,
What
AD
will be
is
AD in terms of UV? In terms of UV. Up to B, it's U. It's V. Up to B, it's V. And up to U, it's up to A, it's U.
V equals to
Okay.
minus A.
So can we write this? This AB is equal to what? OB minus OA. Can we write this? Razi, Advika, Shazan, Farham.
Yes, ma'am, we can write that.
Agree or not? Yes or no? Because AB, this AB, this
Ma'am.
this much. This AB is this much. This whole minus this. Okay.
Okay, ma'am.
So OB is what? OB is what? Is it V or not?
Yes, ma'am. It is V minus U.
Ma'am, it is.
Is it V? It's V. And OA is what?
U.
U. So minus U means AB is what? V minus
V minus
U. And AD is equal to CD. It's also V minus U. Okay, fine. And up to here it's T. This OA is T. Okay. And up to this AO is already we have written that AO is U. So can we write these things in this AD? AD into CD. AD is how much? AD is how much? It's T.
T.
T. Okay. So T into V minus U. Can we write it?
Yes, ma'am.
Plus OE into OA. OA is what? OA is U and OA is T. Means UT. Yes or no?
Yes, ma'am.
Getting confused? Adhika, you are getting or not?
No, Adhika, I got it.
You got it? Any doubt up to here? No. Okay. Now what we'll do? These all are equal to S. Now what we'll do? We'll do what is C. Yes. From this equation. Now you see this equation. Okay. You see in second equation all we need is UAT, right? UAT. We do not need V here. We do not need V here. Okay. In second equation of motion, we do not need what? V. So we have to eliminate this V somehow. Okay. We have to eliminate this V somehow. So using the formula first, using the first equation of motion, we can get V minus U is equal to AT like this. V minus U is equal to AT. We are getting? Yes? So can we write it like this V minus U? We'll write this T as it is. And then V minus U as AT. Can we write it? Yes. And UT will be as this. Okay. What we have got here? UT plus half AT square because there are two things. So can we multiply it? S is equal to UT plus half AT square. Got it? Or
Ma'am, I
not?
didn't got it. Just once.
What you didn't got? What you didn't get?
Ma'am, after S equals to half AD into CD plus.
After
the third step.
this,
Yes, ma'am.
all I have written in place of V minus U, AT. In place of V minus U, it's AT. From the first equation of motion. Here you will write using first equation of motion,
Ma'am,
which
okay,
is
fine.
v minus u is equal to at. So writing at in place of v minus u because we have to eliminate this v from this equation because we don't want v here. Okay, is it fine? Now third equation. It will be too easy to understand. For the first equation of motion, we will use the formula for acceleration. For the second equation of motion, we will find out the area of trapezium by parting it to two parts. Okay, by dividing it into two parts, a triangle and a rectangle, and then in third equation of motion, we will do what? We'll find the area of trapezium as a whole. Fine. We'll find the trapezium as a whole. Again, we'll find the S for the third equation of motion. Again, we'll find S, third equation of motion. Again, we'll find S, which is area of the same OACE, the trapezium. Okay, now we'll apply the formula of the area of trapezium, not the rectangle and triangle. Okay, we'll apply the formula for trapezium. Area of trapezium is what? Half
Half
sum of half sum of
the rectangle plus
parallel
triangle.
side. No. The area of trapezium. What is the area of trapezium? Formula for the area of trapezium. Half
Okay.
sum of parallel sides into height, right? Because in trapezium there is what? There is two parallel sides, right? There is two parallel sides. Either you draw your trapezium like this. There are two parallel sides, this and this. Either you draw like this. This is what we have here. This is also a trapezium because it has two parallel sides, this and this. Okay? The sum of parallel side into height, and half of the sum of parallel side into height. Height is what? This. Height is the perpendicular distance between the parallel side, right? The altitude is what? The height is what? It is the perpendicular distance between the parallel side, right? Not getting. Don't you know the formula of a trapezium?
Ma'am, I'm getting it.
You can just also cut off that part and then put it over there, and that will become a rectangle. So that's how you can calculate it.
No. This time you don't have to use the formula for rectangle and triangle. This time you have to use the formula for
But you already
trapezium.
have the formula, so you don't need to do that.
Yes.
And we already have the formula, so we don't need to do it.
Yes, we already are having the formula for the area of trapezium. Now for the third equation of motion, what we'll do? Sum of parallel side. What are the parallel side? Parallel side, tell me the parallel side. In this trapezium,
Ma'am,
what is the
OU
parallel side?
and OU
No,
and
don't say U. Just U is the initial velocity. Just A is the point. Name of the point.
OA and
OA and
DC.
No.
EC.
OA and C. Yes. OA and C. So OA plus CE. Okay. Into height. Height is what? OE.
Yes.
Razi, you get it?
Yes, ma'am.
Yes, no? No problem now? Anywhere?
No, ma'am.
No problem.
So OE will be OE. Just put the values of OA is how much? Okay, from this OA is how much? OA is U. Is it U?
OA is U.
U. And
And
C is
C is V minus U.
V.
Okay.
DC is V minus U. DC is V minus U. Okay. OA is U and C is V. Okay. And OE is what? T. Is it T?
Yes, ma'am.
Now here we'll see if we do not need for the third equation of motion, we do not need U and all we need is what? We do not need T. Fine. In third equation of motion, what we have?
Ma'am,
V square minus U.
V square minus U square equal to S.
Yes. Here is no, here there is T. So we have to eliminate this T. In the last equation, in the second equation, what we did, we eliminated V, right? In order to eliminate the V, we have to put the value for V minus U so that it will become A. And then ut plus half T square. But here for the third equation of motion, we do not need T here. So for T, again using first equation of motion, again, don't write again. Using first equation of motion, what is it? V minus U upon T is equal to A. Okay? So can we write, because we do not need T. So can we write it like T is equal to V minus U upon A cross multiplied? Can we write this?
Yes, ma'am.
Advika, are you there? Advika is not there. Advika is there. Advika, are you getting? Advika, not listening. Okay, T is equal to V minus U upon A. Can we write it? Yes or no?
Yes, ma'am.
Yes, ma'am.
Now, putting the value for T in the equation. S is equal to half U plus V will be as it is, and then here V minus U upon A in place of T. Okay, fine. V minus U upon A. And now, can we use here the formula, the third identity that we were discussing yesterday? A plus B, A minus B. What is it? A square minus B.
A square minus.
Here we are seeing clearly that here is U plus V, V plus U and V minus U. Can we write it? V square minus U square. Because
Yes,
it's
ma'am.
a multiplication. Because
By
it's
A,
a
by A.
multiplication. So
Yes, ma'am.
S is equal to 1 by 2A will write
By
it.
2AS
And then V square minus U square. Can we write it?
divided by
Because
A.
it's V minus U. Don't write U square minus V square. It will
Okay.
change the sign. Okay, here it's V minus U. So write U plus V plus U instead of V plus U. Instead of U plus U. Okay,
Ma'am,
so
cross
we
multiplication.
cross multiplication. So we'll get 2AS is equal to V square minus U square. Now we can write it like placing this what to do? Bringing this minus U square to LHS side, we'll get V square is equal to U square plus 2AS. Is it okay?
Yes, ma'am.
Right? V square is equal to U square plus 2AS. This is the third equation of motion. What were our steps? What were our
It will
in
be V
nutshell,
square minus U square equal to AS.
yes. So,
Ma'am, but
first
you
step.
something different.
I have written same. Either you write V square minus U square is equal to 2AS or you write V square is equal to U square plus
Okay.
okay. So, what is our steps to derive this formula? This is very important, and this comes in examination. Fine. Steps. First step. What was our first step? To find first equation of motion.
Ma'am, I know. Ma'am, it will be
To find first equation of motion, we use the formula for acceleration. A is equal to V minus U by T. Okay, fine. Now second. For second equation of motion, what we used? Find
use
area
V
of
minus U by T
find
equal to
area of trapezium is equal to area of triangle plus rectangle. Okay, area of triangle plus rectangle. Okay, and then third step is what? To eliminate V minus U. To eliminate V minus U, or to substitute the value for V minus U as 18. To substitute V minus U is equal to 18 from first equation. Okay, and then we'll get the third equation of motion. Fine. Now fourth step is what? Find area of trapezium in the formula of what? Half sum of parallel side into height. Okay, fine. Now, what we substituted? We substituted is T is equal to V minus U upon A. Fifth, substitute T is equal to V minus U by A. Then sixth, using third identity, V square minus U square is equal to V minus U by V plus U. Okay, and then we will get third equation of motion. Only these are the steps. Okay, only these are the 6 steps that you have to take. Fine. After drawing the graph, and there is nothing in the graph. The graph is just this, and you just need to join the rest part. Just join this, and join this. This will be your U initial velocity. This will be your V final velocity, and this will be your T. And obviously, this part will be V minus U, because this whole is V, and this much is U. This part will be how much? V minus U. Okay. Is there anything hard in this? If any one of you are finding anything complicated here,
Ma'am,
anything complicated?
third equation of motion.
Third equation of motion.
Yes, ma'am.
What is that? To find area of trapezium. To find area of trapezium simply, and area of trapezium is what? Sum of parallel side into height upon 2.
Yes, ma'am.
And sum of parallel side we are knowing here. What are the parallel side here? Obviously OA and CD. Obviously, OA and CE. So you will add them and half of it, and then multiply by OE. Means OE is what? This OE.
Height.
This is your height. Okay. This is the
Ma'am, OT is the base.
perpendicular distance. OT, don't
OE, sorry.
write OE. Yes,
OE
OE is not a base. You can say that OE is the height. This is 90 degree, right? This is 90 degree, no?
Yes,
This is
ma'am.
making 90 degree with
Yes,
the
ma'am.
with both of these parallel sides. If suppose you have this, okay? And what will be the height of this? What will be the height of this trapezium? Obviously, this will be the height of this
Yes,
trapezium,
ma'am.
or you can say this will be the height of it. So, if this is your trapezium, then what will be the height of the trapezium? This is the height of the trapezium, and then
Yes, ma'am.
rotate it like this. If this is your trapezium, what will be the height of trapezium? Obviously, this will be your height of the trapezium.
Yes, ma'am.
This will be the height of your trapezium, no? This, because these are parallel sides. This can't be the height. Either you draw like this. Obviously, this will be equal to this. Okay. For any triangle, if you are going to find the height, what will be the height? Obviously, that perpendicular distance is always the height,
Perpendicular, ma'am.
right? For rectangle, it's already perpendicular. So
Yes,
this
ma'am,
is
I got it.
this into this. But for parallelogram, we have to draw the perpendicular and then we can find the height. Fine. So you got it. And if you have already the trapezium and like this, and you obviously your height will be this. Okay. Fine, Razi. This is your height. OE. Okay. And then putting the values. OA is what? U, and OC is what? V. Okay. So I have put the values OA and C for U and V into T. And then for T, to eliminate T from here, because in the third equation of motion, we don't see anywhere T, right? It means that we have to eliminate this part, this T part. Okay, and the only way to eliminate this, we have to use the first equation of motion, which is V minus U is equal to AT. So from this, we can write T is equal to V minus U upon A, right? Because we will need V, we'll need U, we'll need A, but we don't need T. So we'll eliminate this T. We'll write T. We'll write V minus U upon A in place of T. So what this is what I've written here: V minus U upon A. Okay, here it's already V plus U and V minus U. Using the third identity, we'll get V square minus U square. Okay, fine, because this is multiplication. This is also multiplication. This 2 into A, this 2 will get multiplied with A, 2A, and then this 2A will be brought to the other side and forming 2AS is equal to V square minus U square, and then we'll get our equation. Okay, so you have to do it. You have to do it again and again. Then only you will be able to do it by yourself without any help. Okay, so this you can't do in one go. Means like you have understood and you will start. You can do it. So don't think in this way. You have to do it again and again until you can do it in your own on your own. Fine. So this equation of motion is uniform circular motion. Uniform circular. I've already told you about uniform circular motion. That it's. What are you doing, Shazan?
Nothing, ma'am. Mouse. Bringing the mouse.
What?
Ma'am, my mouse is stuck. Actually.
Okay, so we have already discussed something about uniform circular motion. That uniform circular motion is what? Is an accelerated motion. Uniform circular motion is always accelerated motion, and it's non-uniform motion. Okay. Then let's see what is written here. If an object moves in circular path with uniform speed, its motion is called uniform circular motion. Okay. If an object moves in a circular path with uniform speed, fine. Even if the motion is uniform, then it means if the motion will be uniform, then only we can say that the circular motion is uniform. Okay. If the speed is uniform, but the motion is not. The whole motion will not be uniform. Only the circular motion we can say that it's uniform. Okay, because for the uniformity, even the direction should not be changed, right? Even the direction should not be changed, but here the direction changes at every point, so we cannot call this uniform motion. We can call this uniform circular motion or non-uniform motion. Okay, so if we have to give an example of non-uniform motion but accelerated, it must be accelerated and also means accelerated motion with uniform speed. Okay, accelerated motion with uniform speed, then this will be the best example of it. Because speed will be constant, but the velocity will not be constant because velocity includes direction also. And here the direction changes, so the motion becomes non-uniform. Fine. So when an object moves along a circular path, its direction of motion keeps changing continuously. The velocity changes due to continuous change in the direction, and the motion along a circular path is said to be accelerated. Okay, everybody is listening?
Yes, ma'am.
Okay. When a body takes one round of circular path, then it travels a distance equal to circumference, which is equal to 2 pi r. Okay. If body has traveled one round of the circular path, obviously, if a body has traveled one round, then the total distance is 2 pi r. There must be some radius. Okay. 2 pi r will be the total distance. And displacement, we will call it 0. Displacement, we will call it
Displacement will be 0 because it started up at the same. It's identical to the same place that it started.
And if a body has traveled like this much, from this part to this part, then we'll say that the distance is half of 2 pi r, means only pi r, right?
Yes.
Only pi r, and the displacement will be 2r, because this will be your point, this will be your center, and then this will be your r, and this will be your r, means the what? Diameter. The displacement would be the diameter, and the distance will be the half of the circumference if a body has traveled only from this part to this part. Okay.
Okay, ma'am.
The speed of the body moving in a circular path. Obviously, speed will be what? Distance of speed is what? Distance upon time. So distance is what? 2 pi r by t. Distance will be 2 pi r
By t.
right? If the body has traveled from this point to this. Okay.
Okay.
Here t is the time taken for one round of circular, and pi is the constant having value. 22/7. Some of the example of uniform circular motion are as follows: a piece of stone tied to a thread and rotated in a circular with a uniform speed. Like you have tied a stone to a thread, to a thread, and rotated in a circular motion like this. Okay, then it will be what? Uniform circular motion. The motion of blades of an electric fan, right? Electric fan. It is also uniform circular motion. The motion of the moon and the earth. The motion of the moon and the earth. A satellite in a circular orbit around the earth. And then a car is moving on a circular path with constant speed. Okay, these are all the
Examples
of circular motion. Okay, this is your example.
Uniform
Very easy
circular motion.
example. Yeah, this is an example. Very easy example that the time has got from 10 a.m. to 10:30 a.m. So we have to find the distance and displacement. What I told here, if a body has traveled from this part to this part, only the half of the circle, then what will be the distance? Obviously pi r, not 2 pi r, right? You can write s is equal to distance is equal to pi r, and for the displacement it will be how much? 2r, because this much and this much. Okay, the same we have to do this question.
Okay, ma'am.
Fine. So we have completed our chapter today. Right? We have completed our chapter. All we need to do some of the numericals on this. Okay? So you will do some of the numericals in the what assignment, and then let me know which of the question that you got stuck, and then we'll do what? There are some examples in this also. Example 11, 12, 13. Okay? We'll see these examples. I've already shared the handout, right? Already shared the handout for this topic. So you will go through the handouts and the examples of this. Okay, all we need to do put the values in the equation and then find the value for another. Okay, fine. So you'll do these questions, and then tomorrow will be your assignment class.
Assignment.
Right?
Yes, ma'am.
Okay. And next class, I guess when is your chemistry class? Monday or Saturday? When is your chemistry class? Monday or Saturday? Because in case of chemistry class, there is physics class. There will be physics class on Monday or on Saturday.
It is.
Okay, let me
Monday is bio and maths.
Ma'am, Monday is.
Okay, fine. Means on Saturday it's your chemistry. Fine, we'll discuss it. And for tomorrow, you
On Saturday it is test. Bio test.
Bio test.
Yes, I know. Yes.
And Monday it is. And Monday is maths.
Okay, is Abhika there? Why
No,
she
ma'am.
is there? Okay, everyone has got the equation of motion now. You have
Yes,
to
ma'am.
derive.
I got it.
Yes, ma'am.
Okay, so you have to derive it once again. Okay, and many times, not only once again. You have to derive it many times so that you will get it thoroughly. Okay, so bye for today.
Bye, ma'am. Thank